Math 8, Section 1.5, Additional Practice Problems. Here we need to learn how to solve equations. Recall, if we have x minus a times x minus b, let's say, equals 0. To solve this, you set each one equals 0, and then add a to both sides. You get x equals a, x equals b. So this can be applied to any example. Let's say this times 3x plus 7 equals 0. As long as it's 0, then we set each factor here equal to 0. So this equals 0, or the 3x plus 7 equals 0. Add 1 to both sides, divide by 2. You get x equals 1/2. Subtract 7 on both sides, divide both sides by 3. Sometimes the equation is not given in this form. This is a factored form. Sometimes you are required to factor. Say this equals 0. How do we factor this? Make sure it's equal to 0. So what we need to do is factor the left-hand side. Factor the left-hand side. So what do we get when we factor the left-hand side? So it's a quadratic, so it's x, I believe, plus 4 minus 2, and you can test it out. From the preview chapter, we did a lot of these questions, factoring trinomials. So as soon as you test it, 4x minus 2x, that gives me 2x, the middle one. Then we set this equals 0, or the middle one 0. So x equals -4, or x equals 2. How about a different example? Y squared minus 4y equals 12. So to do this, we need to make sure everything is set equal to 0. In this case, to do so, we need to subtract 12 on both sides. So it becomes y squared minus 4y equals minus 12 equals 0. Now we have to factor this one out. Again, it's a trinomial, equals to 0. Then y, maybe minus plus, maybe 3 by 4, no, 12 by 1, no, 6 and 2 works. You can test it out. As soon as you factor it, you set each factor equals 0. Y plus 2 equals 0. So y equals 6, or y equals -2. Another example, 12x squared minus 17x equals -6. Always pause the video, try it on your own first before we show you the actual solutions. In this case, we can add 6 to both sides first. Add 6. Then we try to factor this trinomial with the trial and error, see if it works or not. So, I don't know, the 12, we can try, if we try 12 and 1, okay, 12x minus x, and the 6, because it's a plus, but the middle one is minus, both should be minus, maybe 6 and 1. Tested -6 and -12, -18. That doesn't work out. So then maybe I can break this, maybe use 6 and 2. Let's see, -12 minus 6, no. Maybe 3 and 4. You want to keep trying. 24 and this, no. Maybe keep the 4, maybe try 2 and 3. 2 here and 3 there. That's 8 and 9, 17. That works. 8 and 9. So you multiply these together, -8x. Multiply these together, -9x. So when you add them up, you get -17x. That's the middle one. So that confirms that the factorization is correct. Then for this to equal 0, 3x minus 2 must equal 0, or 4x minus 3 must equal 0. So then add 2 to both sides and divide by 3. Add 3 to both sides and divide by 4. That's what we got. How about if they give us something more difficult, something like this, equals 6, not a 0. In this case, what we need to do, we need to make it equal 0 somehow. The only way to do that is to expand the left-hand side, FOIL it, multiply it, expand it. W times W, W squared. W times 2 minus W2 minus W. Negative, negative, positive 2. It's quadratic, so it means everything must equal to 0. So you can subtract 6 on both sides. So you get W squared. These together minus 3W minus 4 equals to 0. Then we factor this out. W minus 4 plus 1. Right? And you can test it out. So now we set each factor equal to 0. W equals negative 1, W equals 4. So that's one way to do them. We're going to look at what about if I can't factor this out. How do we finish this? So recall, we have what we call quadratic formula. The quadratic formula says if you're solving a quadratic equation in the form ax squared plus bx plus c equals 0, then how do you solve for x? X equals negative b plus or minus the square root of b squared minus 4ac over 2a. So let's say 2x squared plus 5x plus 1 equals 0. We need to solve this. No matter how you try to factor it, it's not going to work out. So in this case, we'll go back to the quadratic formula. This is A2, B5, C1. You may pause the video and use the equation or the formula, specifically the quadratic formula. So it says x equals negative b, so negative 5, plus or minus the square root of b squared minus 4a by c over 2a. Negative 5 plus or minus 25 minus 8 divided by 4. So x equals negative 5 plus or minus the square root of 17 over 4. Done. So this means it gave me two solutions here. One, x equals negative 5 plus the square root of 17 over 4. And the other one, x equals negative 5 minus the square root of 17 over 4. So that's the quadratic formula. Maybe let's say 3y squared minus y minus 6 equals 0. So again, this is non-factorable. Okay, so we use the quadratic formula. A here is 3, B is negative 1, that's the negative 1, and C is negative 6. And you may pause the video and try it on your own first. So we substitute this in. Here we have y, not x. Negative b plus or minus the square root of b squared minus 4ac over 2a. Substitute negative, negative 1, positive 1. So it's 1 plus or minus b squared. 4a is 3c negative 6. 2 times a. 1 plus or minus. 1 plus 12 times 6, 72 over 6. So that gives us 1 plus or minus square root of 73 over 6. We can't simplify 73, so we leave it as is. We leave it as is. Another thing to practice more on here is we call square root property. Square root property, which says if x squared is m, then x is plus or minus the square root of m. So if we have, let's say, x squared minus 11 equals 0, we need to solve this. Or we need to solve x minus 3 squared equals 25. What happens in this case for the first one? We add 1 to both sides, 11 to both sides. Then by the square root property, this is plus or minus the square root of 11. Again, plus or minus means one time is plus, one time is minus. Two solutions or two roots or two zeros. We applied the same way to the next one. X minus 3 is plus or minus the square root of 25. But 25 can be simplified as 5. So now we must split this up. X minus 3 is 5. X minus 3 is negative 5. Add 3 to both sides. Add 3 to both sides. These are the two solutions. We can take more examples. Say x plus 3 halves square is 1 over 4. 1 over 4. Then, how do you solve this? Again, it's already something square equals 1/4. So this means x plus 3 halves is plus or minus the square root of 1/4. X plus 3 halves is plus or minus 1/2. So then subtract 3 halves on both sides. So this gives us x equals negative 3 halves plus 1/2, or x equals negative 3 halves minus 1/2. So x would be negative 1, or x would be negative 2 if we combine them. How about if they ask us to solve same equation, but instead of 1/4, I'm going to change it to 1/2. Make it 1/2. So then x plus 3 halves is plus or minus the square root of 1/2. X plus 3 halves is plus or minus 1 over square root of 2. If we subtract 3 halves on both sides, that gives us this. It would be nice to simplify these or split it up into two cases, one time positive, one time negative. But we learned also, or you can keep it like this, it's fine for now. Now, how if they ask us to solve using completing the square method? Completing the square. Say x squared minus 10x plus 5 equals 0. To complete the square, we keep the x's on one side, subtract 5 on the other side. Divide this by 2. So negative 10 divided by 2 is negative 5. So what do we do with this? We add, so we square it first. That gives us 25. So we add 25 to both sides. Now we complete the square on the left side of this. This is x minus 5 square equals 20. X minus 5 squared equals 20. So x minus 5 is plus or minus the square root of 20. So x equals 5 plus or minus 4 times 5. 5 plus or minus 2 square root of 5. You can keep it like this, or you can split it up into two solutions. Another example, I recommend you pause the video and try it. x squared minus 12x plus 33 equals to 0. Again, you can, from here, you can add, subtract 33 on both sides. Then take the coefficient of x, 12 divided by 2, 6. Square it, you get 36. So we're going to add 36 on both sides. So on the left side, you get x minus 6 squared. That's where you complete the square. On the right side is simply 3. Then, by the square root property, this equals plus or minus the square root of 3. You may add 6 to both sides, and that gives us what we need. Again, you may split it up into two solutions. Recall, when we use the quadratic formula, negative b plus or minus the square root of b squared minus 4ac divided by 2a, the term inside the radical sign, which is b squared minus 4ac, the b squared minus 4ac, we call it delta like this, and this is called discriminant. If the discriminant is bigger than 0, the equation has two different or distinct real roots. If the discriminant is 0, it has one real root, which is repeated. If the discriminant is less than 0, no real roots. We call them complex roots. No real roots. So to apply this to an additional problems, we need to find the number of real solutions to, let's say, 3x squared plus 5x plus 5 equals 0. They're not asking us to find them, they just ask us to state the number of real solutions to this equation. To do that, all we have to do, find the discriminant, the b squared minus 4ac. b is 5, a is 3, c is 5. 25 minus 60, that's negative 35, which is less than 0. Since it's less than 0, no real roots, or 0 real roots. How about 3x squared minus 7x plus 3 equals 0? You may pause the video and try it. How many real roots does this equation have? Well, we find discriminant b squared, which is negative 7, minus 4a3c3. So this is 49 minus 36, which is what, 13, bigger than 0. So the equation has two distinct real roots. Two distinct means two different real roots. Now, graphically, if they give us a graph of a function, even if they don't state the equation, and they ask us just how many real roots does this have, or something like this. We need to find the number of real roots. So to find the number of real roots, here it has two distinct real roots. It's where the graph crosses the x-axis. Where the graph crosses the x-axis. It crosses the x-axis at 2 points, call them x1, x2. So this has two real roots, this one. If you solve the equation, which is not given to us, they just give us the graph, it will have two real roots. This one, you see the graph does no cross with x-axis or touches. So no real roots. For this one, I see it's crossing at 2 points, so two real roots. This one exactly at 1 point, so it has one real root. It's a repeated root, identical root. We call it double root.